So imagine, just for a second, that you are buying a house.
Okay, I like where this is going.
Right. But not just any house. We are talking about a massive, sprawling, incredibly expensive piece of real estate.
Like a real dream home.
Exactly. You've saved up, you've signed all the papers, and now, you want to know exactly what you've just bought.
Which is pretty standard. You want to know what you're getting into.
Yeah, so you ask the builder for a home inspection report. Something in plain English that tells you if the roof is going to cave in or if the plumbing is just fundamentally flawed.
A simple yes or no on the structural integrity, basically.
Right. But instead of that nice, easy-to-read inspection report, the builder just hands you a stack of highly complex, incredibly dense architectural blueprints.
Oh, wow. Just a mountain of paper.
Literally. They drop this massive stack of technical drawings on your desk, and they say, well, everything you need to know is right in there.
Which, I mean, technically it is, but...
But unless you are a structural engineer, those blueprints are virtually useless to you.
Yeah, you can't read them at all.
Exactly. You can't govern your own house, and you certainly can't evaluate the risks of living in it because you simply don't speak the language it was written in.
That is a wildly frustrating scenario to picture.
It is. And yet, today, we're exploring why that exact scenario is playing out every single day inside almost every modern organization.
It really is everywhere, yeah.
Because, we constantly hear about how software is getting smarter.
Oh, yeah. AI, machine learning, autonomous systems, it's all anyone talks about.
Right, but we rarely talk about who actually understands the software we are building.
The people paying for it usually have no idea how it works.
Exactly. So today, we are diving into this fascinating article that was just published today, July 13th, 2026, by Maurizio Rossari.
Yeah, it's a really compelling piece.
It really is. It's titled, "The Software of the Future Won't Just Be Smarter, It Will Also Be More Accessible."
Which sounds simple, but the implications are huge.
Massive. So the mission of our deep dive today is to decode this major proposed shift in technology. We're talking about moving source code from being this locked-away technical artifact into universally accessible knowledge.
And, Rossari isn't just theorizing here. He's detailing a specific, highly engineered infrastructure called the SYRAG ecosystem.
The SYRAG, right.
Yeah, and it's designed to solve this exact translation gap you mentioned with the house analogy. He's putting forward a very concrete methodology to dismantle that wall between the people who write the code and the non-technical leaders who, well, have to live with its consequences.
Okay, let's unpack this, because Rossari argues that the very definition of what source code actually is, it has fundamentally changed.
It really has.
Because we usually think of code as a tool, right? A set of mechanical instructions that makes a database run or an application load.
Like the gears in a clock.
Yeah, exactly. But he says source code is no longer just a technical artifact. It is a form of knowledge.
Which is a huge paradigm shift. Because what's fascinating here is that when you look at millions of lines of code in a modern enterprise system, you aren't just looking at digital machinery anymore.
What are you looking at then?
You're looking at this massive, intricate repository of human decision-making.
Oh, interesting.
Yeah. Embedded within all that syntax are operational patterns, highly specific dependencies, critical risks, and complex design choices.
Okay, I see what you mean.
And every single one of those technical decisions carries a real-world business implication.
So if a developer, say, decides to route data through some third-party server just to save processing time.
Right, which happens all the time.
That's not just a coding shortcut. That's a massive data privacy risk being quietly cemented into the very foundation of the company.
Exactly. And under the current paradigm, that decision remains completely locked away in a language that only other developers can read.
Like the architectural blueprints.
Right. If you're a CEO or a compliance officer or a risk assessor, you are essentially blind to those structural choices. You're governing a system you cannot comprehend.
Which honestly sounds terrifying. But let me ask you this. Is this translation gap a genuinely new problem, or has our reliance on software simply reached this critical mass where this blindness is just too dangerous to ignore now?
Well, the underlying dynamic has always existed, sure. But the scale of the consequences has escalated dramatically.
Because software is everywhere now.
Exactly. Historically, we treated software as a boxed product. You buy it, you install it, and as long as it works, you don't really worry about how the sausage is made.
Right, like an old CD-ROM game. If it plays, you're happy.
Yeah, but today, organizations don't just use software. Their entire operational existence is completely intertwined with it.
It's the lifeblood of the business.
It is. So when the code contains a vulnerability, or if it relies on some risky external dependency, that is no longer just an IT headache.
It's a full-blown crisis.
It's an existential threat to the organization. By pivoting our understanding of code from this simple artifact to an essential asset full of hidden business logic, Rosari exposes this massive vulnerability.
Meaning leaving code exclusively in the domain of engineers is a huge risk.
Exactly. It means the people who carry the ultimate financial and legal risk are completely disconnected from the reality of their own systems.
Okay, but that brings up an obvious counterargument.
Let's hear it.
If the problem is that code is hidden or secretive, doesn't open source software solve this?
Ah, right.
I mean, we've heard for decades that open source is the great democratizer of technology, right? The code is public. Anyone can literally go to a repository and look at it.
Sure, they can look at it.
So why do we need an entirely new infrastructure to tell us what's inside the code if the code is already out in the open?
Because there's a profound difference between availability and comprehension.
Okay, tell me more about that.
Well, open source makes the text of the code available to anyone with an internet connection. But it does absolutely nothing to make that code understandable to a non-technical governor.
Oh, I see.
Just because you can physically see a million lines of C++ or Python on your screen doesn't mean you can spot the nested dependencies or the cascading security implications embedded in it.
It's like handing me an encyclopedia written in ancient Greek.
Yes, exactly.
Sure, the information is entirely transparent and available physically,
Mm.
but I still can't read a word of it.
And that is the exact chasm Rosari is addressing with a module he calls SYRAG Universal Source.
Universal source, okay.
Yeah, and he makes a very deliberate point. The universal source is not attempting to replace open source.
Oh, really?
Right. It's not an alternative to platforms like GitHub either. It is a mediating component designed to sit between the raw code and the human decision maker.
A translator, basically.
Exactly. Its stated goal is to transform technical transparency into universal understanding.
But wait, how does a mediating component actually achieve that? Like if I'm a risk manager looking at a dashboard, what is universal source actually doing to that raw ancient Greek text to make it useful to me?
So mechanically, it abstracts the code. Instead of showing you the raw syntax, the loops, the variables, the functions, universal source parses that code and extracts the structural realities.
Okay, so it looks for the big picture.
Right. It maps out the dependencies, identifying exactly which external libraries the software relies on. It translates those architectural choices into plain language business logic.
Wow, okay.
So rather than reading a block of code, the governor sees a verified report. It might state something like, this module connects to these 3 external databases. It relies on this specific open source library that hasn't been updated in 2 years, and it routes user data through this specific framework.
Oh, that's incredible. It functions exactly like our home inspector.
Yes, exactly, back to your analogy.
It reads the complex blueprints and generates a standardized report that just highlights, hey, here are the load-bearing walls, and over here are the leaky pipes.
And by doing so, it ensures that the software is verifiable and reliable for anyone assessing its implications. It finally bridges that gap between technical reality and business oversight.
That makes total sense. But, I mean, a translated report doesn't really do you any good if the data inside it is outdated, right?
Or fabricated.
Right, or disconnected from the rest of your operations. And this seems to be why Rosari doesn't just pitch universal source as the standalone tool you download to scan your code base once a month.
No, it's much bigger than that.
Right. He positions it as one module operating within a much larger, highly coordinated machinery called the SYRAG ecosystem.
The ecosystem is key.
Because he's proposing a fundamental shift in how we manage the entire life cycle of data.
If we connect this to the bigger picture, the ecosystem approach is really the only way this philosophy actually survives contact with the real world.
What do you mean?
Well, Rosari describes building a conscious data lifecycle. This is particularly aimed at media companies and organizations that manage just massive, constant flows of content and data.
Okay.
If you just slap a translation tool on top of a chaotic, fragmented IT department, you haven't solved the problem at all.
You've just added another piece of software to maintain.
Exactly. Just more noise.
And here's where it gets really interesting, because he specifically warns against building more disconnected tools. The overarching philosophy of the SYRAG ecosystem is about building continuity.
Continuity is the magic word here.
So let's break down how this machinery actually functions together. We have universal source handling the translation of the code, as we said.
Right.
But then he introduces other modules with highly specific prerogatives, like there's the SYRAG Content Manager, which handles digital certification.
Yeah, because once Universal Source translates what the code is doing, you then have to certify the outputs that the code is generating.
Okay, that makes sense.
The Content Manager essentially acts as the verification engine. It ensures that the knowledge flowing through the system is mathematically verifiable and trustworthy.
So it's double-checking the work.
Right. It stamps the data, essentially proving its origin and its integrity.
Okay, and then there is this agent gateway, which Vasari describes as managing secure agent coordination for modular systems.
It's a mouthful, I know.
It is. And we hear the term agents thrown around constantly right now, usually implying some sort of AI doing tasks for us. How does this gateway fit into a system that is so obsessed with transparency and verification?
Well, in this context, you have to think of agents as autonomous pieces of software deployed to execute specific complex tasks,
Like what?
like scanning for vulnerabilities or routing data or even updating systems, all without constant human prompting.
Okay, I see.
But if you have dozens of these autonomous agents running around your network, the potential for chaos is incredibly high. They might conflict with each other, they can create untraceable errors, or even open up security loopholes.
It's like having a factory floor full of autonomous robots, but you have no central traffic control system to stop them from crashing into each other.
That is a perfect way to visualize it. The agent gateway is that traffic control system.
Got it.
But more importantly, it is a secure environment that forces all of these modular agents to coordinate in a way that is traceable and visible to the rest of the ecosystem.
So they can't just go rogue.
Exactly.
Yeah.
It prevents agents from making hidden changes to the code base that the Universal Source module wouldn't be able to translate later.
Which ties directly into another module he mentions, the R&D dashboard.
Right, the research and development side.
Yeah, designed for intelligent research. All of these pieces, the translation, the certification, the agent coordination, they are all governed by a shared philosophy he calls evolution, by exposing errors.
Which is such a great phrase.
It really is, but it also feels like a direct contradiction to how the tech industry usually operates.
Oh, absolutely.
Because the instinct in tech is almost always to quietly patch a bug before anyone notices it.
Yeah, sweep it under the rug. But that instinct to hide flaws is exactly what creates systemic fragility over time.
Interesting.
When Vasari talks about evolution by exposing errors, he is advocating for an architecture that actively surfaces its own flaws as a feature of its growth.
So embracing the mistakes.
Right. If an autonomous agent makes a routing error, or if a piece of code generates an uncertified output, the ecosystem doesn't bury it. It exposes it, it translates it into understandable knowledge, and then it presents it to the human operators so the underlying architecture can actually be improved.
Wow, that actually preserves human capital too.
It really does.
Because you aren't wasting thousands of hours paying engineers to just blindly dig through a fractured tech stack trying to find the source of some obscure error.
Which is what they spend half their time doing now.
Yeah. The ecosystem coordinates the data, it spots the anomaly, it translates the problem, and allows the human workers to actually make informed decisions about how to fix it.
Exactly.
Yeah.
By building this continuous environment where traceability, secure coordination, and error exposure just natively interlock, you eliminate the blind spots.
So the blind spots disappear.
Because the cracks between disconnected tools, that is where the risks live. A continuous system governs itself holistically.
Now, if an ecosystem can truly function like that, translating complex code into verifiable knowledge, certifying the data, securely coordinating its own autonomous agents, that fundamentally alters one of the most painful aspects of running a modern business.
Which is?
Corporate oversight and compliance.
Ah, yes. The dreaded audits.
Exactly. Vasari dives into this concept he calls compliance by design, and honestly, this feels like the most explosive real-world application of the entire framework.
It really represents a radical evolution from how we currently handle corporate governance. He outlines this transition from standard GDPR oversight to what he terms three-layer distributed verification.
So what does this all mean? Because he makes a highly technical and honestly almost provocative claim here.
He does go out on a limb.
He states that the SYRAG operating system embeds strict compliance frameworks natively. And he specifically calls out ISO 27001, the NIST cybersecurity framework, and FIPS controls.
Those are the big ones.
Yeah, and for anyone listening who hasn't had the distinct pleasure of sitting through a compliance audit, ISO 27001 and NIST are essentially these massive, exhaustive frameworks of cybersecurity best practices.
They are brutal.
They dictate everything from how you encrypt user data to who physically has access to your server rooms. And FIPS are these strict federal standards for cryptography.
Right, they are not suggestions.
Exactly. But Rosari argues that by embedding these frameworks directly into the operating system, it makes traditional audits obsolete.
That is a massive claim.
It is. I struggle to see how an entire industry of third-party external auditors simply vanishes just because of a new software architecture. Are we really saying the era of the third-party auditor is dead?
Well, this raises an important question, right? To understand why he makes that claim, we have to look at the mechanics of a traditional audit.
Okay, let's look at it.
Currently, compliance is this highly retroactive manual process. Once a year, an external auditing firm comes in. They ask for server logs, they interview your engineers, they demand endless documentation of your security protocols.
Sounds exhausting.
It is. And they are basically attempting to piece together whether your systems were compliant with NIST or ISO standards over the past 12 months.
Right. It is essentially a massive, incredibly expensive archaeology project.
That's a great way to put it.
The auditors are just digging through your past actions,
Yeah.
looking at the sediment layers of your IT department, trying to prove that you followed the rules.
And because it is a manual reconstruction of past events, it is inherently inefficient. It's wildly expensive, and it's incredibly prone to human error or manipulation.
Sure.
But let's apply Rosari's premise here. If the operating system itself is built with compliance by design, the dynamic flips entirely. In this framework, the FIPS cryptographic controls and the NIST security requirements aren't just a checklist on a clipboard anymore. They are mathematical rules embedded into the lowest level of the operating system itself.
Oh, I see. So the system physically cannot execute a process that violates those frameworks.
Exactly. Furthermore, through that three-layer distributed verification we mentioned, the system is constantly checking its own work.
3 layers. Okay, what are...
Layer 1 is the raw operation. Layer 2 is the translation via universal source. And layer 3 is the continuous digital certification that the operation meets the embedded compliance standards.
Wow.
If the system is continuously proving its own compliant in real time and surfacing any deviation as immediate, understandable knowledge, the role of the manual auditor literally evaporates.
So instead of this retroactive archaeology project, compliance just becomes a continuous, self-evident state.
Precisely.
It's basically the difference between taking your car to a mechanic once a year for an emissions test versus driving a car that monitors its own engine continuously.
Right.
Like, the car physically will not let you accelerate if it violates emission standards, and it prints out a mathematically verified emissions report every single second the engine is running.
In that scenario, you don't need the mechanic to do an annual inspection anymore. The car itself is the inspection.
That is wild.
But that is the essence of compliance by design. The manual audit becomes redundant because the ecosystem is providing continuous, irrefutable proof of its own compliance state.
It just governs itself.
Yes. And this illustrates why embedding these controls at the operating system level is so crucial. You can't just buy a compliance dashboard and slap it on top of messy hidden code.
Right. It has to be foundational.
You have to start at the foundation with universal source making the code fully understandable, and then weave those compliance frameworks directly into that transparent architecture.
Man, it is a stunning vision for the future of digital infrastructure, and it completely reframes how we should be thinking about the software we rely on every day.
It really does.
Let's take a moment to summarize this journey because we have covered a massive paradigm shift today.
Covered a lot of ground, yeah.
We started with the realization that source code is no longer just mechanical instructions. It is a vital form of business knowledge containing architectures, risks, and dependencies. But currently, it's a secretive language that keeps decision makers completely in the dark.
And then we explored Maurizio Rosari's proposed solution, the SYRAG ecosystem. Instead of relying on the superficial transparency of open source, he proposes universal source as a mediating component.
A translator.
Right, a translator that abstracts complex code into plain, verifiable business logic.
And it does this not as an isolated tool, but as part of a conscious data lifecycle. It works alongside the agent gateway to securely coordinate autonomous tasks and the content manager to certify data.
All driven by that philosophy of exposing errors rather than hiding them.
Which ultimately creates an environment capable of compliance by design. By embedding frameworks like NIST and ISO directly into the operating system, the technology shifts from requiring these retroactive manual audits to just existing in a state of continuous, mathematically verifiable compliance.
It's a game changer.
It is. So why does this matter to you? Whether you are evaluating tools for your own business, investing in the future of technology, or simply wanting to trust the digital infrastructure that runs our financial systems, our hospitals, and our media, this is the frontier. We simply can no longer afford to deploy systems that our leaders cannot understand.
Absolutely not.
But I want to leave you with a final lingering thought, something to mull over that builds entirely on the implications of this translation layer.
Oh, this is the scary part.
It is. Historically, when a massive piece of software fails, or a company suffers a catastrophic data breach due to some risky dependency, what happens in the boardroom? Panic? Yes. But then the executives point the finger down the chain of command. They blame the engineering department. They claim it was a technical failure, a complex coding error that leadership couldn't possibly have foreseen.
Because the blueprint was unreadable. The executives have ultimate plausible deniability. They couldn't read the code, so they cannot be held personally accountable for the specific technical failures buried within it.
But imagine a future where the SYRAG ecosystem is fully deployed. A future where Universal Source successfully and perfectly translates those complex codes, those nested risks, and those structural dependencies into plain, certified knowledge.
The translation gap is gone.
Exactly. Knowledge that is sitting right there in real time on an easy-to-read dashboard. If that translation gap is permanently closed, it fundamentally shifts the burden of liability.
It does.
If an application fails or gets breached tomorrow and the exact structural risk was clearly translated, continuously verified, and sitting in plain English on the CEO's desk, who takes the fall, is the executive now completely and unequivocally responsible for the software they deploy?
When technical ignorance is no longer an option, corporate accountability becomes absolute.
When they hand you the perfectly translated home inspection report, you can no longer blame the architect if the roof falls in. You chose to live there.
Exactly.
Thank you for joining us on today's deep dive. Keep questioning the digital world around you. Demand to understand the systems you rely on, and we will catch you next time.